recording now. So basically what we're doing is talking about Glue and the background behind Glue, which is a framework basically for creating web applications, a modular framework for doing that. And today we're going to be talking about this proposal that I created right here, which is a kind of a mid-level file API proposal. So we look here, this is the file API spec from W3C that talks about the various things for interacting with files from your browser. So for instance, if you have an input tag for in your HTML, you can get out a file list that basically shows you the list of files that somebody has, said, okay, I want to submit these files to a form or something like that. There's an interface there. There's a Blob interface, which allows you to deal with kind of raw data of some sort. There's a file interface that built on top of Blob that has a lot of the same functionality, but gives you a little bit more information about the file that it comes from. And then a big one is a FileReader interface, which allows you to read files from somebody's local disk. And so these APIs are fairly old and fairly widely used. Some of them are pretty straightforward, and then some of them are straightforward, but really not that great, or not really that well thought out, at least from today's perspective. I'm sure there are plenty of good reasons why they were created the way that they were created. But one that comes to mind, for instance, is FileReader, which exposes a very finicky API that you can get wrong very easily. So if you're not familiar with FileReader API, basically I have a thing down here. There's a way, for instance, when you create a file reader in JavaScript, and then you need to basically pass in a callback that says, when this thing is loaded, do this thing. And inside of that callback is when you should properly actually read the file call, give me the contents. And if you read the contents before that callback gets fired, which you can certainly do, it's very easy to do, you'll basically get back garbage or nothing. You'll get back nothing, basically. And if you try and read two files at the same time, which again in code is very easy to write, it's very easy to do that thing. It's also, you'll get an exception and says you can't read two files at once and stuff like that. So there are several ways that the API kind of, if you don't use it right, you'll just end up getting an exception or something won't work in the way that it should work. And so basically the point here should be, we should create an API that's a little bit more straightforward. If it compiles, then you can be fairly certain that it's going to do, mostly the right thing. So I want to create an API, for instance, that looks like this, and I can expand it out a little bit more, where you create a file reader and then you call read as text, and I didn't pass in the file that you should that you want to read here, but you pass in some kind of file handle, and then it gives you a future that resolves when the file is done being read. And then once you have that, then you have the contents of the file here, and only then do you have it, and then you can use those contents for whatever you want. And so today my hope is basically to let's get this crate started, even though this proposal is still open, and I'm sure we'll get feedback today. I only submitted it late last night. We'll get feedback today and stuff, and probably will change over the time. There's some things that are pretty straightforward, the FileList API and stuff like that I'm sure will not be that controversial. So we can start creating this crate and get kind of some experience using it, and maybe actually the act of creating it in a way will inform the proposal itself. And so, I'm not the kind of person who just likes to create, whole documents about how a piece of code should work, and then just code against that document. I like to see how the code feels and stuff like that. So that's going to be our challenge for today. Any questions from chat, just let me know. And otherwise, we're going to get started then. So All right. Let's see here. So I have the file open here, or the project open here. And then inside of VS Code as well here. So we're basically going to create a new project then. Inside of here, you can see there's already 2 projects that have been started. So like this won't be the absolute first one, and they're mainly around timers. So there's some kind of there's a library here for basically doing timer-based APIs where you can create a timer, and when it goes out of scope, it will automatically finish timing the thing and stuff like that. So it's kind of a wrapper around how timers work in pure JavaScript here. And it's not super huge. But we're going to go ahead and create a new project then. Let's see here. So we have this here. We're going to go into crates, and I think I can just do cargo new. And we're going to call this, what do they call the other ones? Yeah, let's just call it files for now. Okay, so it's saying compiling this new crate may not work due to it being in a workspace. So we're inside of a Rust workspace, which a workspace is like mini Rust projects all bundled together, and that can be compiled and used together. And so what we need to do then is over here at the top level, there's our manifest file here. And we have here, a workspace, and we also have dependencies. And I think what we'll go ahead and do here is, and I think, yeah, they renamed these. So if we go in here and take a look at console timer, yeah, they gave it the name glue console timer. So we can do the same thing with ours here as well. Glue file. Maybe it should be files. I'm not sure. We can see later. And they wanted every one of these packages to be authored by the Rust and WebAssembly working group, which is fine by me. So now we have the author is proper, version's good. We can already bring in WebSys here as a dependency then, and I'm going to do it in this verbose fashion because eventually we're going to want to have certain features enabled, because the way that WebSys works is very much on a feature basis, so it won't bring in the entire world, because if it did, like, there's a lot of web APIs, and so you have to specifically say, I want to like opt into this thing. So for over here, they said I want the console feature, which gives you the console.log style stuff, but it doesn't give you window and the DOM and all this other stuff. Like, it won't give you everything. Cool. Why not? We'll bring in dependencies. We can bring in the Wasm bindgen test, which allows us to test our code inside of an actual headless browser, which is really nice. Eventually, we want to actually run these in the browser. So instead of having just unit tests, we can have really like actual integration tests that run in a browser, and Wasm bindgen test allows us to do that pretty easily. Cool. So then in here, I guess what we can do is glue, what do we call it? File. And we'll say version is 0.1.0, and path is going to be crates/file. So that kind of mirrors how our others have worked as well. Let me make this a bit bigger. Let me know if anything's too small, and I can bump sizes up. Cool. So let's see if this actually builds now. Cargo build. I want to do it at the top level. Cool. So I don't think we broke anything, which is good. Text size is great. Awesome. Good to know. So let's see here. Inside a file, we can see, so we have one issue where it's created this as a binary instead with main. That's pretty easy to fix. Like we want it to be a library, not a binary. It's pretty easy to fix by calling this lib instead. And we can just say we'll have pub fun foo. So we're going to expose out foo for now. That does nothing. Just to get it up and running and stuff like that. And I can see that RLS is building the world now and stuff. So let me see if I do something bad, will it actually find the error? Yeah, good. Okay, so everything seems to be running fine, which is good. Awesome. Okay, so we have our crate going here. It's compiling fine and stuff like that. And now we need to actually figure out what are we going to do. And I think a really good one to start with here is creating this FileList API that has a bit more richer functionality than FileList in JavaScript does. So if we look in here, and I find these documents to be they're feature rich, definitely. But if we do FileList, the MDN docs are really great for getting just basic overviews and stuff like that. So so these input files basically give you like a list of files, and really all you can do with it is kind of index into them, and it gives you a file at a certain index and stuff like that. So I think first we'll write a wrapper around this, just so like you don't have to deal with the type directly, but then it will just have kind of the same exact functionality as it had with WebSys, which we don't really want, right? Like we don't want to just create a wrapper for a wrapper's sake. But it would be really nice if this thing had an iterator so that we could iterate over our files and turn our files into a vector or something like that. So we have a bit more flexibility around this file list than just having it be able to take an index and that's it. So that I think that's what we'll do first. And let me know if you have any questions about that. Cool. So first thing we're going to do is create a new struct called FileList. I think what it's going to have now is just it's going to take like it's going to have inside of it the WebSys file list internally. So we need WebSys here, and I'm not sure if it exposes at the top level. What we'll have to do here inside of here is make sure that we have the feature that has FileList in it enabled in WebSys. And so if we look at web, I think we can go here. WebSys API documentation. So this is the documentation for WebSys right here. And what we're going to do in here is see where FileList lives. And we can see it here. So this is the actual file list exposed to us from WebSys. And you can see this API requires the following crate features to be activated. Okay, so that's good to know. We need to activate this first, otherwise it won't have it. So we said we want the feature file list. And hopefully now this will be exposed out. Let's see what it's complaining about here. Use. Give this a little space. So now we've brought in file lists here. And saying no file list at the root, but it should be there, which makes me think that our cargo toml is wrong. No file list at the root. Okay, not sure why that would be. Let's see, we're getting a warning here. Unused manifest key dependencies WebSys feature. Okay, so I definitely did. I think it's features. Let's see. There we go. That looks a bit better. And I don't need to run build, I can just run check. So this hopefully will... RLS has a hard time when you change the cargo file sometimes. I find that sometimes I need to just like close the file, and that might help, or sometimes I need to close it completely and reopen it. It's unfortunate. Cool, so we have file list here, and it's complaining because we're redefining file list. So let's go ahead and change that. I like the name file list, so I think we'll keep, whoa, what's happening? We'll keep that name. Okay. So we're gonna keep that name and call this like internal file list. And then we can do internal. Internal file list. Okay. So this is great. We now have our file list struct, and it has an internal reference to it and stuff like that. So again, we're not really doing anything yet. We need to create a method here on file list. I'm not exactly sure how things are normally like created from, like if you have like a internal, you know, you have the websys, like the raw websys thing, and you want to create it. What we can do real quick is just say we're going to create a new file list, and I think here, okay, so there is no new here because you're usually getting file list from somewhere else. You're getting it from some kind of tag or something like that. Hello Farbatel, sorry if I'm pronouncing that wrong. Welcome. So what we're going to need to do, we're probably not going to have a new here that gives you a file list because you're not normally going to create one. What we're going to do instead is have a way to go basically from a file list handle or something like that to create a file list. So like let's just call it from raw for now, and it's going to take internal, which is an internal file. These names are all, you know, temporary. And that should give us a way to at least create a file list pretty easily. So we're going to go ahead and make this public, and we want to make this public too, so that people can actually use it. Cool. All right. Next thing that we need to do is say we're going to have pub fn get, and what pub fn get does is it's going to take an index here of use size, and it's going to return back out an option file, and file doesn't exist yet. We'll create that in a second. And all this is going to do is say, needs to take self as well. So we're going to be able to get files from this file list at a certain index. And we'll say this just takes self here. So self dot internal dot get index. And you can see there already is it's called item here. So it's interesting. I think so they call item here because that's what it exists, how it exists in JavaScript. Like if we look at this here, like there's an item method here. That's not super, you know, normal, I guess, sorry. So they also provide a get, which does the exact same thing, and I imagine one is implemented in terms of the other. I think we're, for now, just gonna stick with get. What is it saying? No method name get, and it needs to have file then here, which is fine. So we got to add another feature here. Close this. And this should hopefully open it up now. And I hope once it builds, it will be fine. The next thing we're going to have to do is have a wrapper around our file as well. So again, we're going to do pub struct file, and this is going to have some kind of internal reference to a file, which we'll call internal file. And we can do that here as file as internal file. I don't know if I really like these names at all, but we'll see what happens. Cool. All right, so we got a pretty easy error to overcome here, saying we expected struct file, but we found the struct websys file, or also known as internal file. So we need to do a little bit of translation because we're going from one to the other. And I think, oops, let's move this down here. So we'll need something like impl file here, and we'll have the same thing from raw. And I don't know if these will be public in the future, but we'll see. So if we say from raw internal, and this is going to take an internal file, and it's going to return back out to us a file, then this is pretty easy. We just say file internal, like this, which mirrors exactly what we did with our file list, so pretty easy. And then we can just call map here to map over our option and say we're going to get internal, and we call file from raw. Maybe we should call this raw. I don't know. We'll see. And actually what we could do here, I like this better. We can just do it like this. We don't have to do the closure syntax. All right, what's it complaining about here? Okay. So it's expecting a U32. That's an interesting thing to talk about here. So this right here, when we call, like when we're accessing on our file list, the type that it exposes is U32. And normally when you're indexing on something in Rust, it's a U size. When we're compiling this stuff down to WebAssembly, usize, by the way, usize is the kind of pointer size, so how big the machine, you know, if you're on a 32-bit machine, it's going to be 32 bits, and if you're on a 64-bit machine, it's 64 bits. So it's like the word size, basically the pointer size that you have on the machine. When we're compiling to WebAssembly, like those two things are the same. Like WebAssembly right now only supports 32-bit integers. Like there is no such thing as WebAssembly with 64-bit integers. It just doesn't exist. So they've hard-coded it here as U32. I'm tempted for now to leave it as usize, because again, it will be the same thing, and we can simply map and say, take it, and then not US32. So convert our usize to U32. If somehow usize happened to be 64 bits, then this would just chop the integer in half. But we can be fairly certain for now that that can't happen. So cool. So we have that. We have really done nothing here other than wrap these websys things and structs, but that's not super interesting. What we want to do instead probably is create an iterator interface for FileList, which should be pretty cool. So let's take a look at Iterator here. An iterator basically is just a way to iterate through a collection. And you can see here, what we're probably going to do here is not implement iterator on the file list itself. Normally when you're talking about collections, you create an iterator struct itself that has kind of either ownership over the collection or a reference to the collection, and this iterator struct is then implements iterator. So it's a little bit of indirection there. So we don't have to, iterator needs some way to keep track of like where it is in the iteration and stuff like that. We don't want to like clutter our file lists with that stuff. So if we look at iter, for instance, on like vector and stuff like that. Let's look at it for vector. I think it's on slice. Doesn't, like when you call iter on vector, that gives you some iterator, and that iterator itself, that iterator implements iterator. So you're going to call iter on vector, it will give you this struct called iter, and that struct implements the trait iterator. A little bit confusing, but hopefully when we step through it, we'll see what that means. So let's go ahead and say, for now, we're going to create a, I'm not going to keep these together. We're going to create a struct called FileListItter. And what it will, for now, it's going to contain nothing. Eventually it will contain stuff. And what we're going to do then is implement iterator for this thing. And what we need here basically is a way to say pubfn iter is going to return a FileListItter here. Okay. And this should be a method of some sort, and we can take ampersand self here. So let's just do this. All right, so what's it saying here? Private type. So we gotta make this public. Chat, let me know, is everything making sense so far? Any questions, anything that you want me to go back and look and talk about again, let me know, and we can talk about it in a bit more detail. Okay, so we have this iter. It doesn't do anything right now, so we want to go ahead and implement, where is iterator? Iterator exists at standard iterator. We'll just do that, standard iterator for FileListItter here. So we're going to implement this trait for this struct that we've created, and should tell us right here what we're not. We need a couple of things. So we're missing item. We need to tell them what item are we actually iterating out, and we need a next function that basically will automatically get called when somebody wants the next item in the iterator. It calls next, and we provide the next item for it. Cool. So this should be pretty straightforward. We want item here. I think I have to do type item equals, and what we're going to do here is we're going to expose out an ampersand file here, like this. We'll get some complaints here in a second, like we're missing a lifetime specifier. So we need to say this is going to take some lifetime A. We're going to make this generic on some lifetime A. If you're unfamiliar with lifetimes here, this is basically a way of specifying like how long something lives, a reference, how long it lives. We'll talk a little bit more about that. This will eventually take a lifetime, so let's go ahead and do that now. And that should do it. This is complaining because it's never used, which we'll go ahead and say this is going to take call it file list, and it's going to actually take a reference to our file list. Now this is going to complain and say file list self. All right, hurry up. Cool. So we've got that all working out, and now we just need to implement the next function. So next takes an ampersand mut self, and it returns an option. Iterators in standard prelude. Oh, okay, that's good to know. So we don't have to. Somebody in the chat was saying we don't have to do this because iterator is already kind of by default included, which is good to know. And when we call next, we're going to get back this item type that we had. And let's see if we go ahead and do unimplemented here. This is just a macro that says, make it work. And if we ran this and if we actually ran this code, it would just crash. Cool. So that's looking good. Everything's kind of working now. So now we can go ahead and implement it. We probably want to go ahead and say, like, what's the current item here, and we'll say that's a usize, and that's going to default to current is 0, and this will keep track of which index are we currently on. And then in here we can say if self.current is greater than self.filelist.len, let's say, which we haven't implemented len yet, so we'll have to do that. Then we can return none. So this is saying, are we past basically, are we past the point where we can't return any more items and just return none then. And this is complaining here, expected, oh, interesting. Because down here, and let's just run unimplemented. And hopefully, why not rely on Git doing that for you? So Chad is saying, why don't we rely on Git, the Git method on FileList to actually do that for us? It's a good question. My cop-out answer right now is performance. Basically, the reason being is if we keep track of here, we can basically return early and not have to call into like the JavaScript APIs that are being exposed to us. Because ultimately, if we don't do that, then we're just going to always call Git, and Git is then always going to call Git on this internal thing, and that's going to cross over into JavaScript, and we can avoid that. So, yeah. That's my answer there, but we could certainly test it and see if one's faster than the other. Maybe it's not worth the extra complexity or something like that. Okay. I mean, we have to call len anyway, which will go to, we could cache len and stuff like that. For instance, we'll see. For now, I'm going to do it this way, but we can, let's do it this way, and then we can come back and kind of optimize later on. But that's totally a good point. Let's call len, and this is going to be a usize, and then I think all that is takes a reference to self, and we can say self.internal.len. Is it len or is it? Don't think it's actually len. Length. Len is more common in Rust, so, and length is more common in JavaScript. So yeah, we could also keep track of length here and say length is here. Let's just do that for now. And then from raw says let length is equal to internal.len. Let's call this. And then, so we're just gonna call it once and then cache the result. Because this is it's an immutable thing, like we're never able to like add more. I believe once it is immutable, that's something that we should be wary about. But our internal thing will be immutable, so I think this is fine. All right. And I think length here returns U32, so we'll just make that a usize, and then we can do self.length here. So we've theoretically saved ourselves some hassle there. We'll see. We might want to actually undo that eventually, but okay. So now we're testing against the current length. Then we're going to get the item and say let item equals let file equals self dot get self dot current like this, and then self dot current. We add 1 to self dot current, and then we are going to return file here, and maybe we want to say like assert file dot is sum. So like our file should always be sum here. Like we know we're inside of the collection. So if we call get, like we should be getting something back. Yeah. So what do we call them here? Oh, this is on, sorry, self.filelist. And this is complaining. Ah, interesting. All right. That's a good point. So yeah, we have an interesting issue here. So when we call get here, it gives us a file. It doesn't give us a reference to the file. Like when we're getting something from a vector and we call get, usually what we get out is a reference to the thing inside of that. So presumably that's fine. And what we can do is just say here that our iterator is not going to return references, but actually the things themselves. This is something we'll need to think about later on. So we can get rid of all this lifetime shenanigans. No, we still want that actually. Because we want to take a reference. Okay. We're still going to like maintain a reference to our file list thing. Okay. So presumably we have something working here. We come in, we check current, we check if that's if current is greater than. So here's something. Is this correct? If current is greater than length. So if length is 2 and current is 2, then this won't work. So we want if current is greater than or equal to length. So for instance, if current is 2, that means we're wanting to get the second. If current is 2, that means we want to get the third item in the list, and so we check and see. And there's 2 items in the list, let's say. So we call current is 2, length is 2, and we want to check is current greater than or equal to the length. We don't need the +1. So again, if current is 2, that means we are looking for the third item in the list. If the length is 2, that means that we only have 2 things in the list. So we've checked is current greater than or equal to it, and if so, then we can return none. Yeah. Okay, so now we have an iterator interface here that returns back to us files, which is good. And once we have the iterator interface there, then that means we get a whole bunch of things for free. So we can do all these nice fun methods on it, like map and fold and collect and stuff like that, which is really nice. So for instance, if we wanted to do something like pub into vec, that takes self and returns a vector of files, then we can just say, oops, we can just do self.iter.collect like that, and it will collect it up into a vector. So that's good to know. Cool. All right, I'm gonna go, like, we've written enough code here that I'm gonna go ahead and commit what we have so far. So let's go ahead and create a branch. Let's take a look at what we've changed here. So we've changed the current cargo.toml to include file. Oops, and we've added the file crate, and that's about it. So we're going to commit here and say add file crate with FileListItter. Cool. All right, so we're good there, and we can kind of go back to our proposal here and take a look and see what else we want to do. That one was pretty straightforward. So the next thing that we have is a little bit more challenging. We have Blob, and what Blob is an object and an interface that basically exposes file-like things to users. So if we look at Blob here, let's see. So this is for the constructor. Let's see. A blob object represents a file-like object of immutable raw data. So blobs represent data that isn't necessarily in a JavaScript native format. The file interface is based on blob. So we have a little bit of a case of inheritance here in JavaScript. We have blob, which is an interface, but it also is a concrete type. Like, you can have blobs running around here, and then file just adds certain kind of functionality on top of it. So what we could do is we could have a trait called blob, and then two concrete types that kind of wrap these concepts. So the trait is blob, and then we have, for instance, a file struct which implements blob, and a raw blob which implements blob as well. That's a possibility. And then basically, I don't know. This one's tough. In my proposal here, I basically proposed that where we expose Rust interface with specific types, file and raw data or raw blob or something, and they inherit that interface. And they would basically be one-to-one translations of the file and blob objects from JavaScript, but just with less stringly typed interfaces, so that we're not going to accept in strings when we know that there are like only certain values that we can accept. We're going to make it a little bit more type safe. For instance, raw data would only accept a known list of meme types, unlike in JavaScript where it accepts a string, and then if it doesn't get the right string, it blows up. We want to just enforce at compile time that people are passing in the correct meme type. It's tough because that works. There's other ways to kind of model this inheritance thing. We can have an enum instead. which is basically, we could say it's a blob. It's either a blob or it's a file. And then, and then you would basically expose internally in that. I don't like that either. Let's try the interface route and see how far it gets. Like, the purpose of this whole thing is not to kind of implement this thing. Again, the proposal is not accepted yet, so this may all change, but instead to kind of try it out and see how it actually feels. I'm just going to continue in this file that we have here, but we'll see what happens. If you're watching and have any ideas about what to do, like, feel free to share them. We can discuss them. Okay, so we're going to have a trait called Blob. And let's see what Blob actually exposes to us. So we have size and we have type. Okay, let's do that. Fn size. It's going to be a usize. And then fn type is going to be a meme type. And we'll create a meme type here. And for now, we'll just say there's only one variety and it's unknown. And eventually we'll fill these in with other meme types that we know we have. We want these to take immutable references to self. And it's complaining because type is a keyword in Rust. So what we can do instead is, let's just call it meme type. All right. Okay, we have a way to construct them. Basically, blob.slice returns a new blob object containing the data in there. And we can construct a blob. And you can see here, for instance, it's taking this string and it's saying that it's application JSON. So we can say here, application JSON. We know that's an acceptable meme type. And I assume these meme types are just kind of the standard meme types that you have. There's some RFC out there with that lists all of them. There's a blob builder. I don't know if we're necessarily going to like, it's deprecated here, you can see, but it's having builder types in Rust is normal. So we might eventually have a builder type to be able to create blobs if it turns out to be a little bit wonky to do it. Cool. And then we know that we can pass in blobs to this file reader. We'll see that later on. And we won't do that for now. Okay. Cool. So now we'll just create a struct called raw. We're kind of overloading raw here. We've used raw to refer to directly to using websys crate, like the websys crate directly in all the types from there. So I don't know if we want to call it raw blob. And I don't believe we can have traits and structs called the same thing. Plus it's kind of confusing. So I think instead we will just say, let's just do this from now, data blob. Cool. Yeah, blob impl. That's, yeah, chat is suggesting calling it blob impl. I don't know, that always comes across as very C# to me. I have seen it in Rust before, but I don't know if we want to go down that route. But yeah, well, like, again, none of this is final and it's all just kind of to feel it out. So we'll see. And then we know that this is going to take internal And it's going to be a blob, and we're probably going to have to create a feature, like enable a feature for this. Let's go here. We can see in WebSys how we get a blob. We need the blob feature. I want to keep this alphabetical, I think. Okay. That's true. We could also just not. So Chad is suggesting use WebSys as raw and then do raw blob, raw : blob. We could also just get rid of this crap up here and just say here, and I almost like this better, like WebSys file list, and we will need WebSys. It's a little bit longer than the raw idea, but somehow it's just more straightforward. And then WebSys file and web. Okay. All right, WebSys blob. Cool. And now we can impl blob for data blob. And we need a size here. And we need a meme type. So let's see. This is providing us, you can see here we're providing slices, like ways to slice up the content. All right, so we have size here, so this should be easy. Oops. It's going to return. Interesting that it's returning an F64. Why would it return an F64? I mean, I know JavaScript numbers can be, they're all floating point, but you would assume that the size in bytes would always be an integer. And it is kind of weird to get an F64 back. I'm going to continue saying it's usize. We'll see if that gets us in trouble. So self.internal.size as usize. We'll see if this ends up causing us more headache than it's worth, but we'll find out. All right, and we need to figure out where we get, this is the type getter and it gives us a string. Cool. So self.type, they did type, did they do E? Type E. Yeah. Type, and we can say match and we'll say if it is application JSON. We'll need to do some testing here. I don't know if you give an application JSON with like capital J, for instance, will it translate it at all and stuff like that. We might have to like, lowercase everything and stuff like that. So we'll see. And we'll say if it's anything else, sorry, this needs to be meme type. anything else, then it will be mean type unknown. And of course, in the future, we're going to want to make this a bit better here. All right. Gonna make our types line up here. Yeah, this is a string, right? Okay. Cool. So we had to turn our owned string into a string slice here, but that should work. Okay. And then we need to go ahead and say we're going to impl blob for file. And we need these two things. And I assume they're going to be very, very similar. Let's even see if this just works. And it does. Cool. We might be able to get away with like reducing the code duplication that we have here, but I'm just gonna leave it for now. Yeah, F64, yes, there are not many files larger than, that's a big number. The maximum F64 is very, very large. So, so yeah, we'll see if we run into issues with that. Cool. So let's see, doing a time check here. We got probably about 25 to 30 more minutes here. So I think what we can do now is start looking into what this FileReader API looks like. And the reason we needed a blob, right, is because we want this should be different here. Let me edit this real quick. Nope, sorry. Edit. Inside of our kind of proposed code here, this should take in a blob of some sort. So it can either be a file or a blob. We want to be able to read it out. So let's go ahead and do FileReader impl FileReader. Oh, sorry, we're going to create a struct here, and I'm trying to do a job of like, you know, if I were to create a way to read files from scratch that had nothing to do with the way it works on the web, I would probably do it differently than this. But I want to keep it roughly familiar. If you're familiar with how it works in JavaScript, like this should feel somewhat familiar to you. It's just a little bit nicer of an API. And I think if we want, at a higher level, we can then create something completely different that is just kind of, maybe it even mimics how the standard library works with reading files and stuff like that. So we can impl reader and stuff like that on file. You know, maybe we want to do that in this level, I'm not sure. All right, cool. And then internal is going to be web sys file reader. We're going to have to create a feature or unlock this by creating, putting a feature in our .toml, and we can see it just needs this file reader feature. Say no, yeah. Yeah, the integer level resolution of F64. Yeah, that's certainly true. Okay. Did we add it? No. File reader. Hopefully this updates properly. Cool. And so what we want to do here is basically return a future back, like we said. We want to create a file reader, and then we want to call read as text, passing in a blob, and for it to create a future. So this is going to be probably the hardest part, and something we're definitely not going to get done today. But we can kind of get the glue set up and then see the glue and see if it works properly. Cool. So let's do impl file reader. And I think we can just go ahead and do fn new, and it's going to return back to us a file reader. And what that will do is create a file reader here where internal is set to websys file reader new. All right. What is it complaining about here? Oh, so it returns the result to us. I guess creating a file reader can fail. Why is the question? Let's look at the MDN docs and see if it says under what examples it can fail. For now, we will assume that it will always pass, and just unwrap for now. If anybody's familiar with why FileReader might not, maybe FileReader is a maybe they're doing it because it's possibly a newer API, and so if you're on an older browser, it won't exist. Not sure. Not sure. Yeah. And there are places where it's not available, like web workers and stuff like that. Maybe it's for that reason. We'll see. For now, we're just gonna unwrap. All right, and then what we want to do, we'll go ahead and make this public and public, and we're gonna create another function, another public function called read. What is it called in JavaScript? Read as. Let's do read as text, and we'll call it read as string. And it's going to, eventually we want it to return a future. Let's say it's going to return a string for now. And of course this needs to take self. Great. And it also needs to take a blob. So we'll say it's going to take a blob of some sort, and this thing is going to be impl blob. Like this. Cool. So let's go ahead and give this a try then. If we say internal, and then if we're looking here, we have read as array buffer, read as binary string, read as text. Cool. So let's do that. Read as text, and then we need to pass in blob, and we need a way of getting at the raw handle here for blob. So what we could do is say I think I want to do create raw blob. This is we're gonna provide a way of getting a raw blob here. Yeah. items is going to take self, and it's going to return out a, this is a struct. It's going to return a blob. Web sys blob. Can we do like this? I wonder if we can say it implements blob and raw blob. We'll see. Not sure if this syntax works. Seems like it does. Cool. So now we need to, we don't actually need to implement it right now since it's not being used. So we'll say, we'll leave that for a little bit. Again, I'm not sure why read as text will blow up. So for now, we're just going to wrap. I'm sure there are definitely good reasons why it would blow up. So eventually we're going to want to handle this. If we look at the FileReader API and just read as text, we can see how it's supposed to be used. I guess not. So basically what it does is you create I don't know why none of this has an actual example here. I want to see some code where it shows how FileReader is actually used. Because it's important to, this is a good one here. So you create a FileReader, and then you want to set up basically a callback that gets called when the FileReader is fully done reading. So for instance, you create this FileReader, create this FileReader, then you set the onload function, which gets called when this thing is fully loaded. And then like you want to set that up beforehand, just in case this is a very fast thing. It won't happen. But yeah, you want to, then you call read as text here. We should be able to pass in an encoding as well. That's important. We'll do that later on. And then you basically only get the result back here once this onload is called. So if you were to call reader.result beforehand, you wouldn't get anything. And so we want to basically make this better such that this can return a future where item equals string here. And we're going to ignore error for a second because it's not what we're actually going to write. So we want something that kind of looks like this. Let's see. Okay. Cool. So to kind of wrap up the day, what we need to look into is futures, which I have experience with futures inside of Rust, but not inside of the Wasm bindgen world. Oops. So there is kind of an implementation for futures that exists inside of Wasm bindgen, and basically allows you to create a stopgap between the two. So we want to use this because we want to be able to, or we want to use the futures that works with this so that we can kind of have a gap or a interoperability between the two. And because futures is still kind of up in the air in Rust, like there's the futures that will be standardized soon, and there's futures that are not yet standard and are in the library. We just want to make sure that we're using the same thing, which happens to be futures 0120 here. And don't fret too much about it being so young. Futures is a few years old, and there's been a lot of stabilization work on it. Probably this will go away and the futures in the standard library will come out of it, but this will stay around for backwards compatibility's sake, and probably will just be bumped to 1.0 fairly soon, within the year, I would imagine. Okay. So we can say futures, and this is a trait. So we're going to want to say impl futures future here. And I believe it's going to say you don't, the trait bound is not satisfied. Yep, that's fine. If we go ahead and say unimplemented, what is it complaining about? Whenever I get confusing messages, I go ahead and just run it here, because it's much nicer to see the errors on the command line instead sometimes. Oh yes, unimplemented doesn't work with impl. Yes. That is true. Does panic though? Because I mean, unimplemented and panic basically are the same thing. So I think both don't work here. I think what we can do instead is just say futures. I think there's something like futures okay, and then we can pass in that doesn't exist. We'll just have to look at the docs here. Futures future okay. Yeah. Believe this will work. Futures future okay. And then yeah, and then yeah, there's also the bang type, but that's not stable. Yeah. Oh, why is it complaining now? Can't infer E, which makes sense. An error here is just going to be, for now we're going to say it's going to be unit. So we have no error type. All right. So we've got something here, private trait blob and public interface. That's true. Private trait meme. We just got to make some things public here. Oh, that's true. In return position it is. Yeah. Yeah, that's true. But I mean, that's not really going to help us here. Raw blob needs to be public. Eventually we're going to want to rework this because we don't actually want to expose raw blob out. We don't really want to expose blob or raw blob out to the world. So we're going to have to work this at some point. But cool. So we've got things compiling. And basically what we want to do now is convert our read as text implementation here into a future of some sort. So we're going to have to actually probably implement our own future. We can start doing that now, but since we're running out of time, we're not going to be able to get there. I think, like, as far as I've seen, the best explanation of how to implement your own future is from the Tokyo documentation. We're not going to be using Tokyo ourselves, but they have really nice docs here. You can use a one-shot channel and a callback. The future is one-shot channel, you mean? So for those unfamiliar, here's the trait future, and we need to basically implement some kind of type that implements future that has a certain item in error, and the item for us in this case will be will simply be a string, and error for now is going to be unit. And Chad is basically saying that we should be able to use a one-shot channel, which I believe is true. So if we look at one-shot here, so basically we can create the channel here. We get a sender and a receiver. And what we want to do is when we're going to pass the receiver into our callback, or sender, sorry. And then we're going to send the result over that sender. And the receiver here, I believe, implements future, right? Yeah. So we should be able to do it that way. So let's take a look at the code here. We can say let what is it? Is it RX? And it's the sender and then the receiver. I think people normally do TX and RX, transmitter and receiver. And then we can do features, sync, one-shot channel, like this. And we're going to do self.internal dot, and we need to figure out how to add the, sorry, we're on Blob. We need to figure out how to add the callback that we want. So FileReader here, and the callback that we're going to add is on load here. That's the getter, set on load here. Cool. So set on load. And this just takes an optional function here. Let's see, I think inside of Glue there's good examples of creating functions. I think for instance in this not in here, we need basically an example of how to create a function, which I've not done before. So I believe if we look here, function, interesting. Huh. Let's see if they have an example here. Let's look at this JSsys have an examples folder. Let's take a look. Fortunately not. Let's see if these can give us, oh, these are just the JavaScript function rs. Let's take a look at the docs again. New no args creates a new function object. Yeah, I think that's what we want. Although, oh no, sorry. And this evals it. That's not what we want. Sorry. Onload. Yeah. Yeah, we need to create a function. How do we create a function? I think there is a way to create a function from a Rust closure. Let's see if I can find a place that we're doing that. Just kind of going around and seeing if this has been done before. So we can create a closure. But is a closure a function? This is tough. Yeah, there's definitely a way. The question is, yeah, casting a closure to a JSys function. Here we go. This is a perfect example of why we want to write these wrapper crates, because sometimes it gets pretty confusing. So let's just take this for instance. Where is closure coming from? Is closure Wasm bindgen closure. So it looks like we need exposure to Wasm bindgen then. Let's go ahead and say we're gonna have Wasm bindgen. Not sure if this has Wasm bindgen, for instance. Nope. Wasm bindgen. We'll just take the same version here. All right. Wasm bindgen closure. Okay, we're going to wrap this thing up here. Set on load is going to take this callback here. And inside of the callback, what we want to do is do tx.send, and we're going to, so the callback here, when we call on load, takes an event here. So now we have to figure out how this will take an event. Which is why I'm confused before why this was saying function, because function is not really a typed thing. Yeah, I think then this will take a JS value, I think. So basically, JS values are like opaque types where we don't know what the heck is going on. And we need to cast it as a certain thing. So, come on. So now we need to cast a JS value as this event. I think using this JS cast. And I believe what we have to do here is say let event equal. So basically we're hoping here that this event, whatever it is going to be able to be cast. And to be perfectly honest, I'm not exactly sure what the event is. So it's this event type here. We're going to get this as a JS value. It's an event of some type. Let's see. And the question is, what type of event is it? Because we won't be able to... You know, what am I doing here? This is not what we need. We don't actually need the event, because all we need is the reader itself. So let reader, we're going to get some borrow checking errors here. That's fine. And basically what we want then, and this needs to stay like this. This can go away. And we want to say txt send reader dot and result. And I don't know if we need result. I would imagine gives us a JS value back. We're now in JSSys. We need to be in WebSys. Yeah, cool. Yeah, so it's going to give us a result of a JS value. We can unwrap that for now. And we need to cast this as a string. And do they give us S string? So we can try that for now. So hopefully this is a really good indication why we're doing what we're doing. And I think the call to send also returns a result, so we want to unwrap that as well. So to kind of end the day, because I need to head out here soon, let's see if we can get this to type check, and then we can kind of run a test here, maybe later on. Oh. What is it saying? Oh. expected, yeah, it's supposed to be a option. And we're going to pass in that callback. And now we need to go back to that thing that was telling us how to convert closures to, do we have that? No! We need to be able to convert a closure to a function. There we go. Okay. Unchecked ref. Let's see if this works. Now like copy pasting code in. And I think this is a flub here. Apparently, or maybe we need to import the trait here. Oh, sorry, chat. You're way faster than me. Every time I say something and then I look down and you've already said it. So apologize for not paying attention to you earlier. And it's saying, I think we don't need this to be an FN mut. So we're deep into closure territory here, where we're passing it the wrong kind of closure then. Yeah, it could be invoked multiple times. I'm not sure. Can we just... All right, well, I have unfortunately ran out of time here, but we made good progress. We know exactly what needs to be done. We're just not quite sure yet how to do it. As soon as we can get this to work, where we have once we have the closure being basically set on as the set on load, or the onload callback, then we'll go ahead and be able to send this thing. Of course, now we can call down here and just return RX here. So this should work. Yeah, we can just map error here. Why is that not working? I thought it was a future. I might have to import the future itself. But anyway, closure has a closure once. Well, that makes it easy, but I really need to leave. So thank you, chat. You were amazing this time around. Thanks for everybody who stuck around. It was definitely one of probably the deepest code dives that I've had in my short history of my stream. I hope to be back next week with something very similar. If you enjoyed it, tell your friends. I'd love to hear your feedback. You can find me on Twitter at Ryan_Levick. So hit me up there. And yeah, I'm off to the Rust meetup here in Berlin. So I hope everybody had a good time, and see you. I won't be streaming next week because I'm at a conference, but I'll be back the week after. So look out for anything happening. I might make some videos or something like that, but I probably won't be streaming per se. So cool. See you around, everybody. Have a good evening.